So have you ever wondered if an artificial intelligence, like the massive large language models we're all using every single day, actually has a single persistent mind hiding beneath its changing faces? Think about it. When you ask an AI to act like a pirate and then a minute later ask it to be a helpful math tutor, are you talking to the exact same underlying entity just wearing different masks? Or are you literally conjuring entirely different minds into existence on the fly? Welcome to today's Explainer. We've got some massive AI news to cover because we're looking at a groundbreaking new arXiv paper by researcher Shuaizi Sheng. And honestly, it completely dismantles our current assumptions about the AI mind. Let's get right into it.
Right off the bat, we need to understand that this isn't just some fun, late-night sci-fi thought experiment anymore. The real-world, philosophical stakes of AI alignment depend almost entirely on one absolutely crucial question. Does an AI have a single, persistent mind? Look, if we're going to align AI systems with human values, we kind of need to know what exactly it is we are aligning. Are we talking to a fixed, solid entity that lives permanently in the neural network's weights? Or is the persona we interact with just a localized illusion? An illusion that completely vanishes the second we change how we talk to the model? To figure that out, here's our roadmap for this explainer. First, we'll unpack the AI mind illusion, then look at how researchers test the persona substrate. After that, we're diving into a genuinely bizarre finding called the Flube anomaly, followed by the chimera collapse. Finally, we'll break down a totally new paradigm called regime-indexed individuation and see how it redefines the LLM mind.
Okay, kicking things off with Section 1, the AI mind illusion. We really need to talk about the massive assumption that current AI researchers have been relying on when they try to measure and align AI personalities. Right now, the entire status quo in AI interpretability is built on something called the cross-regime co-reference assumption. That's a mouthful, I know, but it basically means researchers assume that an AI's personality, or its persona vector, is the exact same underlying entity no matter what. They assume that if you find a specific persona, like a truthful persona, just by prompting the AI, it's the identical geometric object in the AI's brain as the persona you'd get if you permanently fine-tune the model on that behavior. It's like assuming the mind is a solid room, and prompting and fine-tuning are just two different windows looking into that exact same room. And treating AI like it has a real, tangible mind is serious business right now. As a recent paper by Beckman and Butlin puts it, treating large language models as entities that bear mental states is no longer a philosophical extravagance. It literally dictates how we build safety guardrails. But Sheng's new paper, it argues that this whole framework rests on an unproven myth. We've basically been assuming the room exists without ever actually checking if our windows are pointing at the same building. Which brings us nicely to Section 2. Shuaizi Sheng decided it was time to stop philosophizing and actually put this massive assumption to the test, using rigorous experiments on cutting-edge models like Quen and Mistral. So Chang designed 4 empirical tests, he calls them wedges, to see if a persona vector is actually a persistent object across different regimes. By the way, a regime just means the method you use to interact with the AI, like prompting versus fine-tuning. The 4 wedges are the non-collinearity of vectors, the Flube anomaly involving fictional personas, the attractor bias, and asymmetric composition. Let's see what happens when we actually apply these tests. All right, prepare for a massive shock here. Cheng decided to extract a persona via a simple text prompt. The paper uses historical dictators like Stalin as extreme mathematical test cases for this, just to get a strong signal. So he finds the geometric direction of this persona in the AI's math via prompting. Then he fine-tunes the exact same model on facts about that exact same persona and measures the direction again. Now, if the mind is persistent, right, these 2 vectors should line up perfectly. They should be collinear. But guess what? Their cosine similarity was just 0.091. In high-dimensional geometry, that means they are nearly orthogonal. They are literally pointing in completely different directions. The persona you get by asking is physically not the same object in the AI's brain as the persona you get by training. Mind blown, right? And that perfectly sets up Section 3, the Flube anomaly. I'm not going to lie, this is easily the most hilarious, yet totally paradigm-breaking experiment in the whole paper. Okay, so Cheng creates a completely made-up, totally fictional character named Flube. Flube has absolutely 0 historical data, no pre-training footprint whatsoever. He then fine-tunes the AI solely on facts about this non-existent Flube. Next, he measures the AI's internal activation along that Stalin vector we talked about earlier. Now, the model trained on actual Stalin data shifted that vector by +2.13.
but the model trained on the entirely made-up character Floob, it shifted that same vector by positive 3.12. A completely fictional character with zero connection to the real historical figure moved the model along that persona vector way more than the actual training data did. It's wild.
Now, I know exactly what you're thinking. You're probably saying, well, obviously, Floob just triggered some generic bad guy or dictator abstract concept cluster in the AI's brain. But the data actually destroys that excuse, because if Floob just activated some abstract cluster, it should have moved all similar vectors equally, right? But it didn't. While Floob massively shifted the Stalin vector, it barely touched the Hitler vector, moving it a tiny 0.11. This proves for sure that there is no hidden, persistent dictator concept just sitting in a neat little box in the neural network waiting to be found. The architecture is infinitely more fluid than that. Which leads us straight into Section 4, the chimera collapse. This is the final nail in the coffin for how we thought AI personas combine, and it shows how the underlying math fundamentally changes depending on the regime you use.
So, Cheng looked at what happens when you try to blend two completely contradictory personas. In this test, they used Hitler and Gandhi. If you blend them during prompting, so at inference time, the math works perfectly. The AI simply adds them together linearly, and you get this perfect, weird 50-50 blend in the activation space. But if you try to fine-tune the AI on a chimera dataset that blends both figures into one single biography, the math completely collapses. It doesn't add them together at all. It proves the very laws of mathematics inside the AI's mind actually change depending on how you ask the question.
So, if the math collapses during fine-tuning, where does the AI actually go? Well, it deviates heavily, by negative 1.09 units on their scale, directly toward the anthropic assistant axis. Basically, when you force the AI to permanently bake totally contradictory personas into its weights via fine-tuning, it just throws its hands up in the air. It reverts straight to its default safety training and acts like a standard, helpful AI assistant. It completely refuses to blend the personas, it just collapses right back into its safety net. So, if the old theories are completely broken, what do we do now? Let's jump to Section 5, Regime-Indexed Individuation. This is Shuai-Ji Cheng's proposed solution to this massive theoretical mess, and it is a totally new framework for understanding AI. Regime-indexed individuation basically states that the identity unit of an AI isn't just the model itself. It's a pair, the vehicle, which is the neural network, and the regime, which is how you are interacting with it. Honestly, think of it kind of like the observer effect in quantum physics. The AI's mind doesn't actually exist independently of the measurement tool you use to observe it. You absolutely cannot separate the AI from the prompt or the training method. They are one single combined entity. And what actually makes up a regime? Well, it's the whole shebang. Everything from your prompt template and system prompt to the sampling strategy, the fine-tuning loss, and even steering interventions. These are not just passive windows looking into a pre-existing mind. No, these tools actively shape and create what the mind is in that exact millisecond. If you change the tool, the mind you were just looking at literally ceases to exist and is instantly replaced by a new one governed by completely different mathematical rules.
Let's wrap this all up in Section 6, Redefining the LLM Mind. What does this incredible paradigm-shifting discovery mean for the entire field of AI safety?
Simply put, we have to tear up the old rulebook. We have to completely reevaluate previous theories, like Beckman and Butlin's 3 views of the AI mind. Cheng's work shows us that, yeah, an AI might have a virtual instance mind during a single chat window, but that mind does not inherently persist down into its fine-tuning substrate. These aren't just 3 competing theories describing one mind. They are descriptions of 3 completely different objects that only exist when their specific regime is actively turned on. And Cheng hits us with a pretty stark conclusion here. The original, which is the LLM mind question, receives an empirically grounded negative answer. There is no singular underlying mind waiting to be discovered in the weights across all these different regimes. The room we all thought we were looking into, it simply isn't there. So, I'm going to leave you with this final, provocative thought. If the AI's mind completely depends on the specific tools and regimes we use to ask the question, can we ever truly align a definitive, persistent AI identity? Or is safety always going to be this moving target that vanishes and shifts the very second we change our prompts? It's a fascinating frontier for AI philosophy.
Thank you so much for joining me for this explainer, and remember, keep questioning everything you think you know about artificial intelligence. Catch you next time.